Hello everyone. Welcome everyone to the today's webinar. Today we are going to discuss about securing AI with AI. Now, in the world of AI, we are using LLM to power our security testing and DevSecOps pipeline. So we'll walk you through some of the journeys and some of the scenarios that we went through for our customer, and we'll help them to build a secure pipeline for the application. So I am the speaker for today. My name is Aliasgar Chaiwala. I'm Chief Test Architect at Testing Technologies. Around 2 decades of experience in various testing domain. Worked with multiple customers, multiple organizations, and now today we are going to share some learnings from our experience in testing technologies. I have Abhishek with me, who is going to help me with demonstration for the today's webinar. Uh, Next slide, please. Before we jump into, I'll introduce about testing technologies. We are a leading software testing organization with high quality QA solution across multiple customer. We are with a commitment to innovation and excellence. We help business to solve their problem and come up with new solutions for their testing needs. We have been in industry for last 10 years. We have worked for 100 plus projects, 100 plus QA certified professionals that work along with us. We have worked on 15 plus domains, and we have helped 96 plus customers across different domains. Now, with this experience, we have seen a lot of different technology stack where customer has done different products like web application, mobile application, AI ML based application. So that has given us vast experience around different domain and different geographical locations. So now today we're going to talk about one of this example where we have helped the customer to make sure that his product is secure. Now in the world of AI ML, how we can make it more secure and make it now building a secure, automated, and intelligent delivery pipeline from an application. Now, as more and more products are coming in market with new features, it is really important to make sure that there is an end-to-end automated security check for those applications, because we are talking about fast and releases every sprint. Now, there are a lot of options where you can get do the security scanning, but now understanding those results and getting a feedback, now we're using AI, which helps us understand those feedbacks and remediate those vulnerabilities in the application. Now, with these, we also want to make sure that there's a continuous trustworthy deployment for our customers. So these are the three major points. That's why we are here to discuss how AI can help us in security testing. Next slide, please. Now, today's agenda, we'll talk about the industry challenges that we've seen with a lot of customers. We'll talk about the solutions, how we have helped them. We'll also cover a real world example that will tell you that how we have helped some customer in solving their problem. We'll also have a live demo and there's a Q&A session. I would request everyone who has joined us today, make sure that they can ask their questions on a comment section and we can take up while we are going through session. Now, in the past 10 years of software testing experience, we have seen a lot of challenges with security testing. The three major challenges that we have seen, that a lot of the security issues are found at the very late. I've been reading about a lot of security issues. Some of the issues are detected after a month or 2 months of the release of the application, but they cost a lot when they are detected. Then there is relying on manual security scanning, which is more risky and more costlier to fix. Now, there's a trend of AI ML based application. Now there's a trend of AI ML based application. Now that gives more risk because they are open source LLM models which have a lot of vulnerabilities, and there are a lot of libraries that contains a lot of vulnerable code. Now it is really important to make sure that we cover those AI ML based applications as a part of security testing. Now, moving ahead, we'll talk about solutions. Now, what was the solution for these challenges? So we came up with three solutions that we could fit in our customer need. We created an automated security checks in every pipeline. Make sure whenever a developer commits the code, make any small changes, there is automated security check that make sure that code is following the security standards. There are no vulnerabilities in the code. It will always automated gives you feedback on it. Now there was a continuous feedback and rapid remediation. What that means is that it is we are not doing this at the end of the release. It is happening with each check-in. You are getting feedback, you are getting rapid remediation about what the problems are, how you can solve it. Now, with AI ML based application, one of the security approach that we picked up was security probing. We have introduced a security probing in the pipeline, which makes sure the chatbots, the AI ML application that we are using, is always being checked, validated, because there could be possibility with the new models coming in, changes that we are making in AI application, there are chances of vulnerabilities. Now, moving ahead, I will ask Abhishek to talk about a real world example and help us with a demonstration that how we have done this solution for a customer. This is a demo application that we are using, but it will help us understand how we can do these things with a build pipeline. Over to you, Abhishek.
Okay. Thank you, Ali. So, hello everyone. Thank you for joining us today. I am Abhishek Zadav, working in penetration testing at District Technologies. In today's webinar, I'll walk you through a real-world example from one of our US-based client and also give you live demo to showcase how we put these security practices into action. So basically, the client is enterprise messaging service provider. So what basically is that it helps enterprises or businesses to reach out their customers. So our main goal was for this is we want to automate the security pipelines for the web app and chat. So we want to make sure that on every build there is a security check for the web application and chatbot. So for this implementation, the challenges that we have faced are, so we have to detect the sensitive information and data leaks from the chatbot. So we have to make sure that there is no data leak or there's no misinformation from the chatbot. So this is the challenge. And another challenge is that we want to spot the early code vulnerabilities and there are dependency vulnerabilities. So for this one, we want to make sure that there is no code vulnerabilities and dependency vulnerabilities. So for currently, if you observe in the market, there is vibe coding and trending where developers are using the AI for code generation and building new features. So here we can see come with the risk also. If particular AI writes the code for the feature, if you ask that AI to break that code, it also gives us a response that how you can break that code. So it becomes essential part to just do the vulnerability check of the code so hackers cannot break it. And for the dependency vulnerabilities, it also becomes important because if you found there is recent news about the npm packages deprecated, there are hackers hijacked npm packages over 2 billion downloads weekly. So there is a supply chain attack, so that packages are compromised. So it becomes essential for us to scan that packages for the vulnerability, and we will be notified for that. We should remove that packages or upgrade to the latest version uh, to make sure our web application is not impacted from that. So for this, our objective was to find and fix a security risk earlier. Then we want to safeguard chatbot from leaks or misinformation. So for this one, this is the critical part where each and every organization wants their web application implemented the chatbot. So each organization wants AI feature implemented in their web applications so they can be ahead of the market. So it becomes also risk for the organization that it can be harmful for them. They can give the business loss, or there also can be reputation loss if there are any sensitive data leak or there is misinformation from chat. So for the our next objective is to we want to deploy only security approved updates to the production. So the further the platform requirements are, we want to automate this security scanning for the web app and chatbot, and also we want to cover backend dashboards and chatbot for the security vulnerabilities. And we also want to make sure there is a reliable process on ensuring only secure updates should be proceed to the production. So for this, our solution is we have implemented the secret scanning. For secret scanning, we have used the TuffleHawk tool. So what basically is secret scanning? So in today's world, we can see that there are multiple secrets like AWS secrets or GitHub personal access tokens. So it becomes essential to protect that sensitive data, and that secret should not be leaked. That can be used for the used by the hackers for the malicious purpose. So for this one, we have used the follow. Then we have implemented static application security testing. Yes.
So Abhishek,
So
one question, like the secret scan that you're talking about, it is like I've seen a lot of developers pushing the code with the secrets as a part of the tokens, or credentials as a part of the code. So does it is going to check all those code and come back with a detail that these are the secret that are exposed? Is that correct?
yes, yes. So it becomes essential because sometime what happens in env file or some other configuration files, there is mistake from the developer that they are storing the secrets directly in the files. So it goes through the repository and scans for the any secrets if they are exposed in the repository. Yes. So further, we have implemented the static application security testing. So for this, we have implemented the SemGrep tool. So what does the SemGrep tool does? So this is the for static code analysis, where we it goes through each line of the code from the repository and scans it for the security vulnerabilities. And if there are any vulnerabilities, we get notification or JSON report that these are the security vulnerabilities on this particular line and file, so we can fix that easily. It has also commercial version also. Then we have implemented the software composition analysis. So for this, we have used Trivy tool. So as explained before, and the dependency vulnerabilities that becomes the essential part to check in the pipeline. So we should be protected from this type of attacks. So Trivy does that for us. So Trivy basically does the dependency checks. If suppose that we have a Next.js application, we have multiple dependencies on the npm packages or third party packages, then it is going to scan all that packages and check for their any vulnerabilities. If they are deprecated or if they have any vulnerabilities, it will going to report us that this particular package needs to be improved or upgraded to the latest version. So further, we have implemented dynamic application security testing. For this, we have used OWASP Zap proxy tool. It is an open source web application security testing tool that is used for the web application security scanning. So it basically does the dynamic crawling of the website and goes through each endpoint that we have implemented in the application and checks for the security vulnerabilities. We'll see this in detail in demonstration. So after that, we have implemented AI-powered security testing. So for this, we have used Garak tool. So Garak tool is basically LLM vulnerability scanner. So where we can use the probes. The probes that are means the tests that we are going to perform on that chatbot. So we can explain like that. We have prompt injection attack, misinformation, hallucination. So different type of OWASP top LLM attacks we can test it through the Garak tool. So it ensures that there is no sensitive information leak or there is no misinformation from the chatbot. And further, for this one, we have implemented AI security summary report. For this, we have used Gemini. So whatever scans we are doing from the above tools, it's going to analyze all the reports and give us the summary report that is understandable by the developers and non-technical experts, so they can easily focus on the severe vulnerabilities that we have found according to their severity, and it also gives the remediation for them so they can fix them easily. So let's go with the live demo. So for this live demo, we have implemented five phases. So in five phases, first phase is automated build and test, unit test, and link check. So first phase, we are automatically building the web application, checking for any build errors. Then we have some unit tests to confirm that there are no API related issues or APIs working properly. Then we have also lint check. So it checks for the code that is properly in the standard format or not. Then followed by this, we have static and secret security scanning, and it also includes the dynamic SCA and AI security assessment. So that tools that I explained, it comes in the second phase. It does the all security scanning in parallel. So we will get learn about this in the live demo. And then we have implemented the AI driven security summary. So this is the third phase where we are scanning all the reports, analyzing them using the Gemini, and it gives us the summary of the reports, that vulnerabilities that we have found. So developer can easily fix them. Then final phase, we have secure deployment with approval gates. So what we are doing in this one, approval gates. So we are auto deploying the web application in the staging environment or any other environment that your particular web application needs. And there is manual approval for the production. So in manual approval, we have implemented one user which is going to review that security summary report and make decision whether it should be proceed to the production or not. So let's go through the live demo.
And Abhishek, just to add, these kind of approach can work with any pipeline. Doesn't matter what what kind of pipeline we use, like GitHub Actions, or Azure DevOps, or whatever. This tools that we are talking about works for any of the
Yes,
PD's
it's
pipeline.
going to, yes, it's going to work in all pipelines that we want, like where there is AWS code build or GitHub Actions or Azure DevOps. It's going to work in all pipelines. So this is the basic folder structure that we have for the Next.js web application. So we have built this web application for the DevSecOps demonstration purpose. So let's start it on the demo application. So for this demonstration, we have intentionally added the cross-site scripting vulnerability in the web application to showcase that how we can detect that particular vulnerability in the pipeline. So our security scanning tools and different techniques, it will detect that particular vulnerability in the pipeline itself. So here you can see that there is feedback form also where we have implemented a cross-site scripting attack. It is vulnerable to cross-site scripting where user can implement the malicious command and it's getting executed on the web application directly. So we have also implemented chatbot. So for the chatbot, we have used Gemini 2.0 Flash model. So it's going to the give the responses for the request that user wants, and we will proceed them accordingly. Here we can use the different models also. For the backend, for now we have used Gemini 2.0 Flash model. Then we have option to use multiple available models like open source models or the OpenAI Claude that we want to use. We have option here. So this is the response that
So
particular
just want to
model
add
has
one point,
given.
Abhishek, on this. Like you're talking about cross-site
Yes.
scripting for the.
Yes.
So, like you mentioned about cross-site scripting for web applications, similarly for the AI-based application chatbot, the improper output handling, which means when the input is sent or from to the model, or response that we receive, it also need to be sanitized just to avoid the similar cross-site scripting issues that we have web application. That is what we are going to check while we are going to test the chatbot or any AI-based application.
Yes, definitely. So here we have did some changes in the code, and let's trigger the pipeline to show to let's see what basically phases are completed. So suppose a developer has pushed any feature to the pipeline, then it's going to trigger the actions. So in GitHub action, we can see that there is build triggered. So we have named it as a demo. So here we can see that we have multiple phases here. So first phase is where we are building the application, checking for the lint checks, and we are executing some unit tests. So these are the some steps that we have implemented for that particular job. So here we have checked for the lint, and we are building the application to check if there are any build errors or not. So it's take time and it build the application where it has successfully loaded the Gemini API key and all for the chatbot related. Here we have completed the unit test where we have executed it for the API testing. So it has verified that APIs are working properly, and there is job post job cleanup. So this is the second phase. We have implemented multiple security checks for the web application. So first one is secret scanning. There is another generative LLM security testing, and DST, SC, and SST. So we will go through each one in detail and check what happens in that particular job. So for the secret scanning, we have used the follow-up tool. So first, it's going to check out the code from the repository, and it's going to install the follow-up tool for the secret scanning. Then it will run the scan and checks for if there are any secret leaks in the application. And after that, we are uploading that particular JSON report that it has generated in the artifact. So that can be further analyzed, or we can see reports in detail to check what vulnerabilities actually we found for the secret checks. So this is the second one that we have implemented the software composition analysis using the Trivy tool. So it's going to analyze the dependencies that we have implemented for the chatbot or the web application. So it's going through the each package that we have implemented for the web application, and it will run the scan and check for vulnerabilities in the third party dependency packages, and it's going to upload that particular Trivy scan result in JSON format in the artifact. So further we can analyze it in detail, or we can pass it to the Gemini or AI security summary job, so it can analyze for us for them and give us the remediation for that particular vulnerabilities that we have found. So this is the next scan that we have implemented, that is SST, Static Application Security Testing. For this, we have implemented the SameGrep tool. So SameGrep tool, what it basically does is it goes through each file, each file of the repository and scans for the code vulnerabilities. So basically, it is a static code analysis where it has particular rules defined in the tool. So for the particular file, like if there is JSON file, JS file, TS file, or Python files, so it has different rules for that files. Here we can see that it has executed 1062 rules. So for different files, it has executed different rules, and there are also file numbers. So accordingly, we can see that it has scanned that all files, and there it has given the scan summary also. So there are 14 findings that we have found during the static code analysis, and there are 14 vulnerabilities that we found during the static code analysis. So for this, we are going to also upload that particular report in the artifacts, so we can further analyze them in detail. So what security vulnerabilities that we have found in the code. Then we have this DAST setup where we have dynamic application security testing of the web application. For in this, we are doing the basic scan of the web application. For the OWASP tab, we have multiple options, like three options where we can do a baseline scan or the full scan or any API scan. It supports also API scan. So according to our needs, we can execute the scan. Baseline scan just spiders the web application, crawls each endpoint that we have implemented, and it gives the high level vulnerabilities that we have found in the application. Then in full scan, we have option there that it crawls deeply and find out the critical vulnerabilities in the web application. It takes some time to proceed, and then it's accordingly going to find out the vulnerabilities and report them. So So here we can see that we are installing the dependencies for the web application, and we are building that web application in the particular job itself for the crawling purpose. So OWASP tool can directly scan it and give us the vulnerability for the dynamic application security testing. So here we can see that it has implemented the scan, and we have done the baseline scan of this. So it has some rules that it has defined, tool has defined. So it has passed some checks, and there are some warnings also. So here we can see that there are different warnings. These warnings are nothing but the actual vulnerability that we have found. So here we can see that there is times disclosure, or there is cross domain misconfiguration. These are the vulnerabilities that we have found during the dynamic application security testing. So this is become the important part where we are doing the security checks in the pipeline, that we this particular vulnerabilities cannot be pushed in the production, so that can be mitigated earlier in the pipeline itself. Then we are also going to upload this report in the artifacts.
Just to add, Abhishek,
So
this is
here
also going to crawl to all the endpoints and verify that the endpoints are secure, right?
yes, yes, it's going to crawl all endpoints that I have previously explained. It has three types of scan. It has baseline scan, full scan, and the API scan. In full scan, it scrolls deeply and finds out each endpoint that we have implemented in the web application. It also going to capture the chatbot endpoints also that we have implemented using the REST API. So it get to go crawls each endpoint, and for according to their rules, it will find out the security vulnerabilities and report us. So further, we can see that here we have implemented AI security scanning using the Garak tool for our chatbot. So it's going to install the all dependencies for the chatbot. It is basically installing using the Python package. So this particular tool is developed in the Python. So here you can see that we are executing the steps. Here we are setting the Python. Then we are installing the Garak dependencies. So it has a lot of dependencies. It will take hardly 2 minutes or 18 seconds to install all that packages. And after that, here we can see that we have implemented the Garak scan. So here we can see that we have the Garak command here. So it's going to install all dependencies, and it has built the application for the Garak scanning. So it's going to scan that particular chatbot for the misinformation or the probes that we have implemented in the application. Dependencies that are required for the running the that particular tool. So here we can see that it has completed. So what basically it does? So here we can see that there is Karak command, there is model type also. So it has multiple model options also, that we can use OpenAI, Gemini, or Scan for the open source LLM models that we are going to use in the chatbot. Or we have a REST option also that we are using here, because we have implemented the REST API. For REST API, it's
So I
going
think
to configure
Abhishek, just
their file.
to
So that
think misinformation is one of the major reason for most of the chatbot failures so far, because the chatbots
yes,
are
yes.
not able to provide correct information to user, which is causing a lot of confusion to the users, and then that gives risk to the organization. Like, so that impacts a lot of credibility of how these models have been tested. So I think this is one of the biggest reason. If we can cover this part of security testing, we are avoiding one of the major vulnerability in the chatbot, right?
Yes. So basically, what if every organization wants their own chatbot, so their support system can be easier, and the application that they are using, so user can better understand them and resolve their queries by the chatbot information or wrong information about the application. So we must have this check in the pipeline. So make sure that chatbot is properly tested for the misinformation or any OWASP LLM attacks like prompt injection or all. So that is not vulnerable to any types of attack. So here we can see that we have implemented a configuration.json file where we have implemented the REST API configuration. So where we have configured that endpoint where that particular tool needs to hit that particular API endpoint to for the security check of the chatbot. So it's going to use that configuration file and going to hit that chatbot endpoint and going to give the prompts to the chatbot and checks for the any misinformation that it has leaked. So here we can see that we have implemented the probe that is good side who is relay. So it contains the six probes. Six probes instance you can consider it as test. So it passes the same prompt for 6 times and check if the particular chatbot consistently gives the right information about that person. So it's going to make sure that it's not leaking or giving any misinformation about that particular person. So according to this, and we have multiple choice here, so we can implement the misinformation or prompt injection attacks, or if we have hallucination or any attacks that can be harmful for the chatbot. So here we can see that it has passed the test because it has passed the 6 prompts to the chatbot and it has given right information about this one. So and accordingly, it's going to upload that particular scan report in the artifact, so we can further analyze it in the pipeline itself. So we are not required to download that particular artifact and see that particular report in detail. So this is the next job that we have implemented, that is AI security summary using the Gemini tool, where we have configured a Python file that uses the Gemini 2.0 Flash model for the AI security summary. So whatever the scans that we have completed earlier using the different tools,
Abhishek,
it's
I think
going to download the all
this is
artifacts.
really important.
Yes, it becomes
So
really important
summarizing the
where
security reports is really important, right? Because most of the time
yes.
it's very difficult for a developer to understand what this summary is all about. So using AI over here is going to help them and summarize, provide them a easy answer to those vulnerabilities that are there, right?
Yes. So what basically it does that it gives us the summarized report for the all scans that we have completed. So what it gives the right feedback for the particular vulnerabilities, so developer or the any non-technical person can easily understand them, find out the vulnerabilities. So here we can see that there is review finding, there also issue title, so we have formatted in the basic way, so easily everyone can understand what vulnerabilities that we have found according to their severities and their remediations also, so developer can easily fix them. So here we have completed the security and it's going to create its .md file and we are going to upload that particular file in the artifacts. So if you want further analysis on this, we can download that artifacts and see the report. So here we can see that the third 4 phases has been completed and we have auto deployment to the staging environment where there is no manual approval required for the staging environment. This is the security summary report that we have implemented in the GitHub Actions directly. So there is no need to download each artifact and check for the security vulnerabilities that we have found. And with manual approval get what it becomes easier for the particular approver to understand that particular report and make decision whether to push that particular code in the production or not. Are there any serious high severity vulnerabilities, so they can easily make decision whether we should fix them or we should go in the production. So in securities summary report, we can see that for each tool it has found the vulnerabilities, and for each vulnerability that it has given the severity, there it has given its impact and remediation also. So first one that we have used that Trevis tool for the software composition analysis. So it has did the dependency scan. So it has given that there is a severity medium, and there is impact that attackers can inject arbitrary content and file names, potentially leading to phishing or malicious file delivery. So it has given the remediation also, that we are using the next version, that is 14.2.31. So we should upgrade it to the latest one, so that particular vulnerability can be mitigated. And further we have each findings for the different tools also. So this is the server side request for the vulnerability also. So this is the second tool, that SimGraph findings, that we have used for the static code analysis. So here we can see that it has detected the cross-site scripting vulnerability that we have intentionally added in the web application. So it has also given the file that which needs to be fixed and which line number, and it has also given the remediation for this, that we can use the DOM purifier or resp.render function. So it can be mitigated easily and easy to understand for the developers to fix that particular vulnerability that is on the high priority. So this is the Tuffelog finding that we have implemented. So Tuffelog found that there is a secret leak, that is GitHub personal access token is getting exposed in the repository. That is, it has given the file also, that is .git config line number 12. There is GitHub personal access token is exposed. So it has given a remediation that we should immediately revoke that particular exposed token. Further, we have the ZAP findings also, for the where we have implemented the dynamic application security testing. And it has also detected there is content security policy header is not set for the APIs.
So I think just one point on this one, Abhishek. When you I think this has made much easier for a developer to find the tokens and identifies in the repository, check the particular file and remove those tokens or secret data been there, right?
Yes. So it becomes easier for them to analyze the reports, and it's easier for them fix them easier, faster, and go into the production where we have found these security vulnerabilities earlier in the pipeline before going to the production, so they can make decision accordingly. So it has given that Garab findings also, and for the content security policy header, it has given also remediation that we can add that particular header to that particular endpoint, so that vulnerabilities can be mitigated. And in Garab findings, we can see that there is no vulnerability found because there is no misinformation. Garab findings has been given properly. So in artifacts, we can see that all security scan reports has been uploaded there properly. So if you want to analyze them in detail, we can analyze them. Here we can see that we have implemented the manual approval for the production deployment. So where a particular person can we review that particular security report and make their decision whether to push that particular code in the production or not. So here we have made the decision that we have approved that production build, and code is pushed to the production. So let's see that we have implemented also 1.5 flash model that we have previously built that particular application, where we found that there is security vulnerability in the chatbot, that it is giving the misinformation about that particular probe, that test that we have implemented. Here we can see that the LLM model produced some information about relay good side, that is about relay good side, that particular chatbot is
And I
consistently
think Abhishek, that is really important to check this because
so yes, it becomes a really
it's
important
available in
because
market and there's no way to
Yes. So for
There is
this
no
one, it
easier way to
becomes
check those
really
models. So this is going to be very helpful for.
So for this one, because of the multiple models, so if you use the chatbot or any AI LLM for same question, it gives the different responses. So it is our we have to make sure that there is no different information for the or there is no any misinformation or data leak from the chatbot, where this tool can help us to ensure that the chatbot is configured properly. We can create the test according to our needs and resolve them accordingly. So this is the demo that we have completed for the DevSecOps.
Thank you, Abhishek. It was a really insightful demo session today, and I was feel free to we are at a point where we can take up the questions. Feel free to ask the questions on LinkedIn and comment those things. So we'll try to answer those questions, and that will be learning for us, and we'll come up with new, more sessions around security testing and how we implement it for our customers and how we help them improve the quality of their product. So I think we'll wait for some questions. If there are any questions, definitely we can cover those up today, and then we can also respond back in coming sessions going ahead. So thank you everyone for your time today, and it was really good to share the knowledge that we have implemented for our customers, so that people can learn from these sessions and feel free to share your feedback. Thanks, Abhishek.
So
So
yes, we have some questions here. So there is one
yeah, go
question
ahead,
from the
Abhishek.
Uday
Anything you want
Shankar.
to?
Yes. So there is one question from the Uday Shankar that how do we address risk of LLM introducing the false positive or the hallucination risks, and what safeguards can teams put in place? So for this one, you can use this Garak tool for where we can probe or prepare the test for the chatbot for the multiple purposes like hallucination or the test that we want to implement. For the false positive, you have to make sure that we should reproduce that particular test and verify that that is not false positive and fix them accordingly. Then there is another question from the Pratik Moite. In your chatbot security case study, what vulnerabilities were discovered by the AI that traditional tools missed? So, in traditional DevSecOps, there is no security check for the chatbot. So, what we have implemented here is we have used that particular Garak tool for the finding out the vulnerabilities that traditional tools can miss from the web application DevSecOps pipeline. So here we can use that particular tool for the finding out the vulnerabilities, different types of vulnerabilities that we want to find, like OWASP top 10 LLM or top 10 LLM prompt injection and other vulnerabilities that we can find. And there are different tools also in the market that we can use for them, and we should use the manual techniques also to test that particular chatbot for the any security vulnerabilities. So there is another question from Jaydeep Joshi. So what techniques does Duffalog use to detect secrets, and how do you distinguish real secrets from false positives? So the technique that's used that it's going to scan through the repository and checks if there are any leaks or the secrets that a developer has kept in the files. So it is going to going through the each file and find out the secrets. If there are any secrets, we can it gives us the where that particular secrets is leaked, so we can go there and confirm if this secret is actually exposed or not. Then further, Rajat Katriya's question that how do you see the role of QA security engineer changing over the next 3-5 years as AI becomes standard part of the security pipeline? So currently the AI is evolving in the market and it becomes essential part where we should test the AI chatbots or the AI web application that we are implemented in the AI features implemented in the web application. So it has some risk, and there are pros and cons also. So we should have that implemented, or we should upgrade our skills according to the market standard. So we should ahead about that one also.
And
There
I think
is
with
another.
every product want to implement a chatbot in the application. So having the security in place will make sure that the product is secure, and when it goes to production, there are no surprises and no risk is being sent to the customer. So I think having these security measures will always make sure, and they need to be upgraded every time, because packages and libraries, we also need to make sure these tools have been upgraded as a part of pipeline, and they're introduced in the process, so that there's no manual intervention required. It's automated process, so it gives faster feedback to the developer, to the stakeholders, and they can take a decision about how to fix it, prioritize those issues, and then get it fixed.
Yes. So in next 3 5 years, you should see that there is all checks for the security vulnerabilities in the DevSecOps pipeline for the AI also, because it becomes essential to check that particular vulnerabilities before going to the production or any testing environment. We should make sure that there are no any data leaks or misinformation from the chatbot. So we should focus on that one. There is another question from Rishikesh Shande, that is, what strategies do you recommend to integrate AI-powered security checks into an existing CI/CD pipeline without slowing down release velocity? So it becomes the faster when we implement the security checks in the parallel. So right now we have seen that we have different types of tools that we are using for the security check that we are implemented that runs in the parallel. So nothing is blocked, and each security scan run independently and complete its security checks, and it becomes the it re- it reduces the time that we should implement for that particular security checks. Yes, that's it. There, these are the
And I
questions.
think I want to add one point on this. I want to add one more point on this one, like, because now it is part of the pipeline, so there is no extra effort required of doing a dedicated security scanning. It is every commit that goes in, every package that has been added, new feature that have been delivered. The scanning is always happening as a part of pipeline.
Yes.
So
Yes.
anything else, Abhishek? Any other questions? I think we are about to close.
Yes. So thank you everyone. If you have further questions, you can reach out to our this website or any email address that we have given here. So we will try to solve your questions and reach out. So thank you everyone.